Okay, another video that we're going to talk about today, another topic is combining like terms. And this is something, again, that you've seen before. It's review. I just want to make sure that you kind of have a visual of what we're talking about, and then also that you have some example problems to go back and look at. So I'm going to be using some of these little magnetic algebra tiles. And so in your notes, it might be a good idea for you to kind of draw out and go along with what we're doing. And the key is already at the top of your notes, so you can copy that down into yours if you're doing it by paper pencil. So the large squares are going to represent an x squared. The rod, or the long skinny rectangle, is going to represent an x, and then the small squares is going to represent the number 1. Okay, and so we're going to use those in that key as we answer a couple of questions. So we're going to start with the first example problem with combining like terms. And all that the combining like terms means is that we're just combining common variable terms and constant terms, things that are the same, putting them together just to make it more simplified. Okay, so you have your key in front of you. I'm going to go ahead and move mine to the side so that I can show you what I need to show you. Okay, so we are going to start with this problem in front of you. 3 plus 3x squared plus 2x, and all of that is being added to the expression 2x plus 4 plus x squared. So I'm just going to represent this using our algebra tiles. So 3 means that I'm using 3 small squares. So on your paper, I would suggest you draw the 3 small squares so that you can see what it is that we're talking about here. So we have 3 small squares, so that's my 3. Then we have 3x squared. Okay, so that means I have 1, 2, 3, all right, x squared, that's the large squares. And then we have 2x, so that means I have 1 and 2 of these x squared, so I'm just going to slide those over, make them nice and neat, okay? And you can draw those on your paper however you want to, all right? And what I'm going to do is I am adding that to 2x, which is another 2 of these rods, okay? Just similar to when you were younger and we were using these as base 10, okay? So there's 2 rods. 4, right, represents 4 of the smaller squares, 4 of the ones, and then 1x squared. All right, so we are adding these things together on our paper. All right, so if I were doing this on notebook paper or on this Google Slides, I would just kind of draw out my squares and rectangles using that feature, the shapes feature. But if I'm doing paper, I'm going to be drawing those on here. So I'm going to replace mine with a drawing so that you have it. So I'm going to start up here. I have 3 small squares, okay, and then I had 2 of the rods, and then I had 3 of the larger squares. All right. And then I added to that, I'm going to get rid of this over here. Actually, I'm just going to white that out to make it easier so that you don't get confused. All right. And so I am adding that to this 2x, which was the 2 rods, the 4 smaller squares, and then the 1 larger square. Okay, all right, so there we are. We've got this expression represented by our algebra tiles. We've got this expression represented with the algebra tiles, and I'm going to add them together. Okay, so we'll start with the biggest and go to the smallest. So the x squareds, this is an x squared, this is an x squared, this is an x squared, and this is an x squared. So how many x squareds do we have? 1, 2, 3 plus 1 is 4. So I end up with 4 x squareds. Okay, and when I go to write that, it is written as 4x squared, 4 times x squared, because there are 4 of them. So 1, 2, 3, 4, 4x squared. All right. Then I'm going to move to the smaller rods here. These are an x, and this is an x, this is an x, and this is an x. So I have 1, 2 over here, 3, and 4. So I have 1, 2, 3, 4 x's. All right, 4x. And then lastly, I'm going to go with these single numbers. So there's 1, 2, 3. So I'm going to draw over 1, 2, 3. And then I've got 4 more. 1, 2, 3, 4. So each of these represents 1. That's 1, 2, 3, 4, 5, 6, 7 for a total of 7. Okay? And so my final answer here, once I've combined all of the things that are similar, is 4x squared plus 4x plus 7. That's what I'm left with. Now, some of you might be tempted to try to combine this further, to make it smaller, to make it 15. Well, the problem is that we can't do that because this x squared is not the same as this x. So I can't add them together. If I add them together, it doesn't work. It's like adding an apple and an orange. Okay, you've heard that before. It's adding two separate things. This is an x squared, this is an x. I can't add them together because they're not the same. So I can't add the 4 of these to the 4 of these. Same thing goes with these and the single, 1. I can't add this to this because they're not the same. Okay, so that's why when we come down here, that x squared, there are 4 of them, we combined them, the 3 and the 1, that's as far as I can combine that. Over here I had 4 of the x's, I had 2 here and 2 here, I combined them, that's as far as I can combine them. And then over here, 7 of the smaller squares, I had 3 here and I had 4 here, and that's as far as I can go on those. Okay, so hopefully that makes sense. We're going to do a couple other examples, and then I am going to show you a few more examples in another video.